Hi, in this video we are going to do the convergence, test the convergence or divergence of these series using the integral test. Okay, first question. Listen the first question. First of all, this is n equal to 1 to infinity 1 divided by n square plus 1. So we have to check that this is f of n is equal to 1 by n square plus 1. 1 by n square plus 1. So this f of n is always f of n is equal to, this is a square type. So for n equal to 1, n equal to 2, n equal to 3, this is always greater than 0, which implies this is positive. Positive. And we need, this is a polynomial function, so this is always continuous. So this is a continuous positive function. We have to show that this is decreasing. Decreasing means f of n plus 1. Find f of n plus 1. This is 1 by n plus 1 square plus 1. We have n plus 1 is greater than n. N plus 1 square is greater than n square. N plus 1 whole square plus 1 greater than n square plus 1. So 1 by n plus 1 whole square plus 1 is less than 1 by n square plus 1. Therefore, f of n plus 1 is less than f of n for every n, which implies f is decreasing for every n. So we got f is positive, decreasing, a continuous function. We can apply the integral test in this. We can apply the integral test. So integral from 1 to infinity, find this f of x dx. Find 1 to infinity f of x dx. This is equal to 1 to infinity 1 by x square plus 1 into dx. This is actually limit b tends to infinity 1 to b 1 by x square plus 1 into dx. This is equal to limit b tends to infinity. This is tan inverse x varies from 1 to b. It's equal to limit b tends to infinity. This is tan inverse b minus tan inverse 1, which is equal to tan inverse infinity minus tan inverse 1, which is equal to pi by 2 minus pi by 4, which is equal to by 4 2 pi minus pi, that is pi by 4. This is the answer in this. So which is a finite value. So integral 1 to infinity f of x dx has a finite value. So it converges. So by integral test, sigma n equal to 1 to infinity 1 by n square plus 1 converges. 1 by n square plus 1 converges. Okay. Similarly, we can do this next problem. Sigma n equal to 1 to infinity log n divided by n. Okay. Log n divided by n. So here f of n is equal to log n by n. We know that this log n is always greater than or equal to 0. This is always greater than 0. This is positive. Next, we have to check whether this form a continuous function or not. This log n is defined for all n greater than 0, and this is for all positive. For all positive n, this is always greater than 0. So this is a rational function type, and this is continuous. So this is continuous and positive. Okay. Next we have to check whether this form decreasing sequence or not, series or not. Right. For that for decreasing or whether this f of n. So we have to check this. Since it is log n, we cannot check like in the case of the first problem. So I'm doing f dash n. That's equal to, what is the derivative? N into 1 by n minus log n divided by n square. That's equal to 1 minus log n divided by n square. 1 minus log n. Log n is always, n tends to infinity, log n is always greater than 0. 1 minus log n divided by n square, which is less than 0 or greater than 0. That is, we have to look at. Okay, when n tends to infinity, this is always greater than 1. So this is always positive. So this is negative value actually. Okay, look in the textbook how they showed that. This is that if log x is greater than 1, this is, if log x is greater than 1, that is log n is greater than 1, then f dash x is less than 0. F dash n is less than 0. F dash n is less than 0. Okay, so that is if n is greater than e, n is greater than e, that is e raised to log n greater than 1 means n is greater than e, then f dash n is less than 0. That is if n greater than 3, we can say that f dash n is less than 0, which implies this is decreasing for n greater than 3. So we can say that integral 3 to infinity, find f of x dx, which is equal to integral 3 to infinity log x divided by x dx. Substitute log x is equal to some t, then 1 by x dx is equal to dt. So I can write this as t dt. T dt, that's equal to t integration is t square by 2. T square by 2, and I can convert this as log x square by 2 from 3 to infinity. This is equal to 1 by 2 into log x whole square. That is log infinity whole square. That infinity comes from limit. This is equal to limit b tends to infinity. 1 by 2 is taken outside. Log x square from 3 to b. It's equal to 1 by 2. Limit b tends to infinity. Log b square minus log 3 square, which is equal to log infinity is infinity, so that's equal to infinity, right? So the series does not converges because the value is different, that is equal to infinity. So the series diverges. What about the next question? What about the next question? This is 1 by n raised to 4 in this. In this question, this is 1 by n raised to sigma n equal to 1 to infinity, sigma n equal to 1 to infinity, 1 divided by n raised to 4. 1 divided by n raised to 4, which implies here f of n is equal to 1 by n raised to 4. 1 by n raised to 4. So this is positive decreasing, and 1 by n raised to 4. When n is increasing, 1 by n raised to 4 is decreasing. And this is continuous. This is polynomial type rational function. So we can apply the integral test. Integral 1 to infinity 1 by x raised to 4 into dx. That's equal to 1 to infinity x raised to minus 4 into dx. Which implies limit b tends to infinity integral 1 to b x raised to minus 4 dx. Which is equal to limit b tends to infinity x raised to minus 3 divided by minus 3 from 1 to b, which is equal to minus 1 by 3 into b raised to minus 3 minus 1 raised to minus 3. That's equal to minus 1 by 3 into, this is 1 by infinity raised to 3 minus 1 actually. This is equal to 0 minus that is equal to 1 by 3, which implies a finite value. That means this integral converges, so this series converges. Okay. So next question, look at the next question. Sigma n equal to 1 to infinity e raised to minus n. E raised to minus n. Here f of n is equal to e raised to minus n. This is 1 by e raised to n. E raised to n is always increasing function. So 1 by e raised to n is always decreasing function. And this is always greater than 0. This is always greater than 0. And this is positive. E raised to x is continuous. This is 1 by e raised to x is continuous. So this is continuous, positive, and which is decreasing also. Therefore, we can apply 1 to infinity e raised to minus x into dx. Is equal to limit b tends to infinity integral 1 to b e raised to minus x dx, which is equal to limit b tends to infinity minus e raised to minus x from 1 to b. Okay, which is equal to limit b tends to infinity minus of e raised to minus b minus e raised to minus 1, which is equal to limit b tends to infinity minus of, not minus, that is e raised to minus 1 1 by e raised to minus 1 minus e raised to minus b. Okay, so this is equal to e raised to minus infinity is 0. So the remaining is e raised to minus 1, that is 1 by e, which is a finite value. Which is a finite value. So the series converges. So the series converges. Okay. So the series converges. Next, look at the next example. N e raised to n is also same as in the case of the fourth one, right? So what about